So let's look at some of the causes of plate movements. Now, since we have plates that are moving at constant speeds, we know that there's not just one force, but three forces that actually work together to move these tectonic plates. And the first force comes from mantle convection. And convection, or convection currents, or mantle convection, is really just this rising of heated mantle. So the mantle from the core gets heated up and then rises to the surface of the Earth, getting closer and closer. This rising of hot mantle. Now, as it rises to the surface, it goes along the bottom of the plate and eventually drops back down and then cools. So this mantle convection is actually causing the plates to move. What happens as the mantle rises, it actually strikes the lithosphere, this area of crust and upper part of the mantle, and causes friction all along the surface. And that friction is pushing the plate away, moving the lithosphere, moving the plate in this direction of the mantle convection. So that's one of the forces that is working. The other occurs at a ridge, and it's called the ridge push. And ridge push is when magma pushes its way through the crust, comes up through the cracks in the crust, and as it comes up, it cools and it starts to build up along the edges here. And as it cools, it starts to sink back down into that new mantle. And this sinking away from the ridge actually pushes the plates away. So this ridge push, all a result of that magma coming up, cooling, and pushing on the rest of the plate. So it's like someone standing at the edge of the table and pushing on it is going to move the entire plate. Now the third way is called slab pull. And what slab pull is when these convection currents act on the surface, what happens is not only is it pushing along the top here, but it is dropping down and pulling down. And we can also think about all of this mass down here. As it gets deeper into the earth, gravity starts pulling as well and contributing to that slab pull. So we have all of these forces working together. We have the mantle convection, the ridge push, the cooling at the plate, pushing the plates this way. And we also have this slab pull that's occurring. And these three forces together, working simultaneously, are causing the plates to move. The movement of plates can have a major effect on the Earth. First of all, when we have two plates colliding together, these two plates collide together, and where they collide together, they can form uplift mountains. So one plate crashes into the other, and over time, it bends, it lifts itself up, and it creates this mountain range. And this is how mountain ranges, much like the Himalayas, where India is crashing into Asia, were formed. Now what's also happening during this, and if we look at this little blue dot right down here, this is going to be our point of origin, and that point, if it's now down here in between the plate, and there could have been water between those plates, an ocean, over time, that blue point is actually going to be pushed up. And so what was once on the bottom of the ocean can eventually make its way to the top of a mountain. And we see this in our own province because this is really how a lot of BC was formed, the crashing together of two plates. And this also explains how, if we go into the Rockies, we can find fossilized remains. Remains that were once at the bottom of the ocean have made their way up to the top of a mountain through this uplifting. We also may have things like a volcanic belt or an island arc. And a volcanic belt is really this. One plate goes under the other, And as it goes under, in that plate, there's water that's trapped. And that water will eventually evaporate because of the heat and find its way through the plate and make its way to the surface. And what we have is this subduction zone, and parallel to that, we have this belt of volcanoes. If this was to occur in the ocean, same principle applies. One plate goes down, it finds its way up, and then we get these volcanoes. And now these volcanoes are often under the ocean, but if they make their way to the top of the surface, then we have this island arc parallel to the converging boundary. So island arcs or volcanic belts, they appear along converging boundaries. Well, also along converging boundaries are these trenches, ocean trenches. And as two plates come together, they two slide together. Just the sheer force of them sliding together is going to cause this bending of the plates. And that bending is where we get these deep, deep trenches. The deepest parts of the ocean lie along converging boundaries in these trenches. We also might get a ridge, a mid-ocean ridge or a rift valley. And a rift valley is really just when two plates pull apart and there's land in between. So if we have this plate and it's diverging and diverging, the land in the middle is actually sinking down. It is going down and creates this valley of land. Now these valleys can actually be very, very populated by different species. And an example of the type of valley, a very famous rift valley, is the East African Rift. And we have a diverging boundary where two plates are actually pulling apart right in here. You could look on your map as well, and you'll see that that's dropping down. Now over time, these are going to split further and further apart, and eventually this ocean water will take over. So we have these rift valleys. Now that's the same principle that applies in the ocean. As two plates pull apart, we could get this mid-ocean ridge, much like the mid-Atlantic ridge. And we're going to spend some more time looking at these effects of plate movements in more detail.